everybody, and welcome. I'm just going to, Michelle, you actually are a... Hi, Developer Steve. I'm joined here with Developer Steve and the awesome Michelle Howie. We are your hosts for tonight. Michelle, I will pass over to you after sharing my screen, though.
Indeed. Thank you. I'm going to go ahead. So we'd like to begin today. Before doing anything, AusIOT is going to get started by acknowledging the traditional custodians of the land on which we're all meeting on today. I myself am in Ghana land in South Australia, but post in the chat the traditional land that you guys are meeting on today. Some of you are also in South Australia in Ghana land, and some of you might be somewhere else. So we wish to pay respect to the elders that are past, present, and emerging on all of the lands on which you guys meet and work. And in the spirit of reconciliation, we also acknowledge that sovereignty was never ceded on these lands, but that we're really grateful to be here and working from them. So thank you, Ali. I'll hand back to you.
That was ace. And just quickly, I'm on Wurundjeri land here in Narromine, which is in country New South Wales. And hello, and thank you all for joining us.
Hi guys, and I'm on Bunurong Boon Warung land here in rainy Melbourne today. So welcome to AusIOT. This is a special episode for us. Night meetup, I should say, but also an episode. It does look like an episode with Steve's background anyway. So we've got a bit of an agenda today. We're going to do a few news and events items that Steve's put together for us. And then we've got three awesome speakers today, so looking forward to that. The first one up is Andrew McDonnell. He's here even though he's got dinner plans with his wife for her birthday, so thanks for joining us, Andrew. And he's going to have a quick chat on IoT, agricultural supply chain security, super important topic. Following that, we've got the awesome Ben Peterson from IBM. He's going to talk to us on opportunities and challenges in Australian Agtech. And this came from a chapter in an AIIA or AIIA, one of those, a white paper that was released recently. So super excited to hear about his work in that. And finally, we've got the amazing Michael Forrai, who was an ex-colleague of mine from Accenture and moved over to Agerris, an agricultural farm startup. So I'm really excited to hear about their journey, and he's going to be chatting on innovation with AI, robots that helps farmers. Following that, we're just going to have some networking so you guys can share projects with each other, chat to us, geek out on IoT, all the fun things we like to talk about. Here's some jokes from Developer Steve, probably. And go for
Ali, speaking of jokes, how do you make a 4D printer?
How do you make a 4D printer, Steve?
You take a 3D printer and give it some time.
I love that joke, actually. I really do like it. I think it's actually one of Steve's better ones. So that's a treat for everyone here at AusIOT tonight, Steve. For those of you that haven't seen this venue before, and you've probably played around with it a bit already, this is a venue called Remo. We like to use this because it's interactive. You can sit at tables, you can jump around tables and talk to each other when we're not in presenter mode, that is. So currently we're in presenter mode. Just a few quick tips for doing that. One of the main tips, I think, is you can actually enlarge your tile view. So if you are chatting and you're struggling to see the person that you're chatting to, there's a tile view button down the bottom there, which kind of changes your view. I think that's one of the best tips. And then obviously camera on, off, mic on, off. There's a whole venue chat as well. So please feel free to put any questions that you have today in that chat, or any comments you have in that chat. We'll be keeping an eye on that. There's also a Q&A tab as well. So if you do have questions for our presenters today, please put them in there, and we'll make sure to ask the presenters at an appropriate time, probably at the end of their talk. So I think that's about it for our venue welcome. And we hope you enjoy it here on Workshop Island. It's raining here, so I like coming out to a bit of summer. We've also got a code of conduct for AusIOT. Obviously, I think everyone here is really awesome people, so I don't need to tell you, but it's inclusive, diverse, respectful, and friendly. So thanks for following that. We've actually got our old Melb IoT code of conduct there. Funny that we're Melbourne IoT. I'm the only one from Melbourne here at the moment. If you are from Melbourne, I need some friends, so post in the chat for me. Thanks to our host. So I'm developer Ali from IBM. I'm joined here by Telstra dev Michelle, and developer Steve is from Sneak. Those sneaker pimps over at Sneak there. So I will hand over to you now, developer Steve, to talk about some news and cool stuff.
Woo! All right. So this is just going to be really, really quick. But if you can click Ali, please. Next slide. There we go. For those of you who missed it, like about a week or so ago now, this one's really interesting. And Michelle and the amazing folks, industry-wide have contributed this, but Michelle's can talk about this more also in the breakout sessions as well. But the federal government is looking to bring IoT security standards as mandatory into IoT projects or IoT deployments, which, well, it's going to affect the entire industry. And obviously there's good sides and downsides to this, but ultimately it's about protecting, sensors in the field. It's about protecting data. So, but I just wanted to mention this as a heads up. Which actually fits nicely with our next slide. If you could please click Ali. Because I found something really cool.
Yep,
there we go.
It's nicely with our first speaker, which is a weird coincidence, but
it does as well. But I've actually pre-ordered one of these. So this is the flipper. Essentially, I mean, it's not really designed as a pen testing device or a penetration testing device for IoT things. But you can use it as an IoT testing device, which is really cool. Totally worth checking out. There is so much tech things in there. It's got RFID, it's got infrared, it's got a little screen with a dolphin on it. You can't go wrong with a little screen with a dolphin on it. But it does a whole bunch of really cool things as far as pin scanning on devices and hardware penetration testing, or IoT hardware penetration testing, which is what it can be used for. So anyway, I just wanted to share those two things. And
can see why it's called Flipper Zone on the screen then, or Flipper Zero, I should say.
The Flipper. I mean, one of my other favorite things on this thing is it's all open source. So the code's available, like you can contribute to it, you can expand it like really easily. So we all have open source.
That's awesome.
It's really cool. Totally ordered one. So maybe in future, once they arrive, I think that it won't be till early next year, but yeah, I'll do a talk around it.
Yeah, sounds good. You'll have to tell us what you build with that, Steve. All sorts of fun things, no doubt. So some more LEDs for your hoodie. Have you got them going yet? I think last time I spoke to Steve, he was putting some LEDs in his hoodie, so it could be super cool.
I actually did, but I haven't soldered them yet, and the risk of fire is real. So
especially with your hair.
Yeah, wearable fire. I'm just adverse to that. Yeah. Anyway, it's coming.
Some exciting news as well. We've actually created a Discord because we felt like, once a month catch up wasn't enough, and there was questions coming in between. And we also wanted to be able to talk to the community, between events, not just once a month. Say hi, bye. But hopefully have some real conversations and talk about what people are working on in between, or help each other out with our IoT issues. So we've created a Discord channel for that, and hopefully someone can post the links for that. I can't copy them off the slide, or you can just use that one at the bottom. Actually, it's probably easiest. Thanks, Michelle. Perfect. So we'd love to have you all join us there in the Discord. It's, free range. No one's moderating this per se. Obviously, be respectful, the same as you would at the meetups, but I know you guys all are.
Code of conduct.
Yeah, code of conduct. But I know you guys all are, so I probably don't even need to say it. But yeah, there's been some good convos in there about things people are building already. So we'd love to see you there between meetups if you would want to join us. So now on to the talks, really. And the first talk is from Andrew McDonnell, and surprisingly enough, talking about security. So I will invite Andrew to the stage. So Andrew's a embedded systems and security engineer from Solinnov. Let me just find him. Andrew, I've added you as a speaker now, so you'll be able to jump up on the stage. But I know Andrew, who's from Adelaide, has also successfully led and contributed to a diverse variety of projects Hi, Andrew. Welcome.
Hi.
Including being co-founder of Platform and working on agritech project Century Farm. So I'm very excited to hear from Andrew, and everyone wish Andrew's wife a happy birthday as well, because I know it's her birthday today. And she's good enough to let you be here and still talk to us. So she's a keeper by the sound of it.
Yep, very much so. Okay.
So welcome, Andrew. I will stop sharing and I will let you get started.
If I do this.
Just while you're getting set up, reminder for everyone that's watching, put all your questions into the Q&A section or in general chat, and we'll get to them after the talk.
Yep, 100%. Good reminder. Thanks, Steve. I knew there was a reason I brought you tonight.
So I know Adelaide is Kaurna country. I'm not quite sure whether it is where I live, which is to the north. Also, I'm here representing myself, not Solinnov. So this is like a side passion, I suppose. Also, credits for the photo go to James, who's in the audience. It's designed to attract attention, basically, because it's a pretty much burned out header. I'm not sure. My wife might even be there in one of those uniforms too, because she's the captain of the local CFS. So the point of today is just awareness raising about security and ag tech, because agriculture is kind of important. And for that reason, I've kind of taken a kind of ag layperson / model approach to agriculture that probably oversimplifies a lot of stuff. If you're a real farmer or doing real security work or various other things, you can probably see I may have been a bit loose with my definitions and made up my own words in a few places. So it's more about just getting people to think about the importance of, if you're going to build IoT systems or other computer systems in ag tech or that work with farming in general, just to consider these things. So information security, which is security in the bottom, comes down to three main things: confidentiality, integrity, and availability. Where confidentiality means there's information that we need to potentially prevent other people from seeing. Integrity is that information not corrupted or changed without our wanting it to be, and availability is that information there when we need it. And that applies to farming and agriculture. So I'm just going to take a quick side bit because I thought this was kind of interesting. 10,000 years ago was, I guess, roughly when modern farming started, and there's a few notable inventions along the way. And things started amping up a bit more recently. So here in South Australia, the stump jump plough was invented. So Australia has a long track record of people hacking things together to solve problems in farming. And I'll let you read the rest of that. And then in 2007, the first iPhone kind of kick-started the whole smartphone and apps market, which kind of changed things in many industries, including, of course, agriculture. And so in terms of thinking about agriculture, I kind of applied a bit of a system engineering approach to it and made a bit of a silly diagram. But when it comes down to it, it's like any other system. You have inputs, there's a process that processes those inputs, and you have output. And so if you're an ag and you're growing a plant, you start with a seed and you have water and fertilizer and soil and sunshine, and eventually you harvest it, and then it goes further along and people process it into an end product that we can eat or drink. And what is often implicit or not obvious is that agriculture is driven by information. And I've posed a whole bunch of bullet points there, but basically it's like, when do I do things? What do I need to do when I need to do it? What do I need to plan for in the future, and what can go wrong? And I guess if you've been doing any IoT or computer projects in agriculture recently, you're probably actually trying to address some of these questions. And the other key thing, of course, is, for the most part, agriculture is a business. So whether you're a sole trader or a large company working in the domain, it has all these other problems that business has, including human resources and health and safety and how to manage your money and your markets, and something called provenance, which means basically, is the product that ends up on your, we'll call it in quotes, end user, which is a customer buying a meal in a restaurant, actually come from where they say it's come from, and is the fish actually the type of fish you say it is, for example. And as I was thinking of this, I was thinking about supply chains, because a lot of inputs going into producing something on a farm, and then between the farm and it reaching your dish, there's a lot of output processing. Those are supply chains. And I kind of made up my own term for this. I decided just agriculture has a double-sided supply chain, just to make it a bit easier to think about the problem. Because really, where a supply chain starts and ends in anything we have is probably arbitrary. But in terms of working in something like IoT, probably most IoT products or projects often work on what I might describe as the input side of the supply chain. Whereas you have a lot of maybe enterprise or logistics problem with computer products on the output side of it. So there's this kind of difference that in some ways they're not different, but it might help divide the problem up if you're trying to think about this. So the output side is what comes from the farm and goes to processing in other areas of the economy and eventually ends up at the table. And so your farmer might produce raw crops for export, or they might sell some of their products direct to the end consumer, or they might recycle it into other products that they also produce, like saltbush or straw, or they might compost it and use it as fertilizer, or they might send it to some other industrial process like sugarcane to be later made into sugar, which later gets made into other products which you then eat. So it's a complicated supply chain because there's lots of different parts to it depending on what your end product is and what your input material is. On the other hand, on the input side, you have everything from seed or your animals you might use to breed your sheep, or the diesel for your tractor, or water, whether it comes from the sky or irrigation, and of course sunshine, whether you're typical what people think of with a farm, or if it's hydroponics or other indoor farming. And of course, soil and additives and on and on and on it goes, and even people and GPS systems, all these parts are inputs. And the other thing I realized is that the supply chain is actually recursive. So as I mentioned before, your output from one farm might be an input to another farm. So it's all turtles all the way down in some ways, if you think about it. Where am I going with this? Well, farming is information intensive. We've got so many different inputs or so many output processes. And if you're a farmer, you're kind of in the middle of that. You need to know where your particular enterprise sits. But in recent years, more and more of this is no longer in the farmers' heads. It's getting moved out of the farmhouse and into tractor systems and control systems and in the cloud and with customers and vendors. And a lot of this has happened without people necessarily thinking about it. And suddenly we have all this data about how you might manage your farm being shared with other people. And not just being shared, but it then exposes those interfaces between your farm and your farm's information with other people to other actions. So a modern farm these days will have digital notebooks and farm note keeping software and digital imageries and input. James is in the audience and can probably tell you how they have self-steering tractors now that do most of the work for you. If your GPS wasn't there, you'd have a big problem these days. And of course, being a business enterprise, modern farming is becoming more reliant on modern accounting systems like, for example, Xero, even though there are probably other ones farmers use. So the thing to keep in mind with all these external systems is the cloud is just someone else's computer. And again, someone who's trying to run a business or a farm, it's not the first thing that necessarily comes into their head because they've got more important things to worry about. And of course, with inputs and outputs, there are interfaces, which are processes, how you grow and produce your output, your normal business processes, the supply chains, like I've mentioned, the wider society and trends, which may influence what you grow or what gets sold in the end. The climate is obviously an interface along with changing climate, and what I've called custodianship. So there's some recent developments around, or it's probably always been there, but now it's been focused on because of climate change, where we can use potentially farmland for regenerative agriculture or to sequester CO2 in the soil. And to manage all that stuff effectively, you need computer systems to keep track of everything. And so we've come around full circle. Having all these inputs and outputs and processes and interfaces and types of information, you've got to worry about the confidentiality, integrity, and availability of this. And this is all particularly relevant because if you're going to design an IoT system or any other computer system that's working in agriculture, and this is relevant to what Michelle posted before too with the IOT security standards, is your farmer and the people providing the services, the IoT system, need to worry about the confidentiality of this data, the integrity and the availability. And of course, farming is a business, so just like any other business, you've got to worry about financial data and personal identifying information because there's legislation around that. And in any case, not just for a farm, if that gets compromised, you can have your bank account drained or whatever other risks that the media likes to popularise and so on. And of course, there can even be intellectual property. Depending on your farming business, you might need to protect seed. I was going to use the word models, but that's the wrong word, but seed breeds or tricks, you use to graft your plants together so that you can outcompete your competitors at the next Royal Show. Or perhaps recipes if you're in the supply chain and you're making Kentucky Fried Chicken. I guess it's a silly example, but you get the point. I've used a winery as an example. That's in Agtech, agriculture, but they can employ many people, and therefore you have to worry about legislation. And if you fail to take account of a leak properly, you can actually be subject to fines if your business is large enough. And then integrity of information. So one thing to consider is sharing is a principal value for farming, because farming is a collaborative enterprise to most traditional farmers. They will need to share information. They all look at the same rainfall history or earth observation. I know there are projects in our district where there are some weather stations and the farmers can all log in and access that data. But you need to worry about the integrity of that shared information, because if for some reason or another it got compromised, then no one will trust it anymore and that system becomes useless. The other thing is past information is a key driver for their decisions. So, for example, past yield history on a crop or the condition of the soil. And if for some reason you had 20 years worth of digital records and they all got destroyed because you didn't get backed up, you might have a problem making future decisions. And biosecurity I've added there because even though that's not strictly information, it's still of relevance. If we get a disease in that affects our farm, it affects the farm's ability to do business. So security in information overlaps into security in other domains. And just one real world example, you might have designed a digital system to allow farmers to capture chemical spraying records. Now, if they got modified, that could actually lead to a legal liability on the farmer for not complying with the relevant law. If the spray got out and poisoned the next door neighbour's garden or something. The last one is availability. So infrastructure is critical, obviously. A bushfire might destroy a crop or machinery might be damaged. And of course, lots of modern machinery is full of computers now. And I've used an example there I saw somewhere on the internet. Cows actually need to be milked regularly, and if they're not, they can get sick. So if you have a computerized milking machine that's connected to the internet and then someone, I keep using the word hacks in, but if the machine breaks, whether maliciously or not, then what do you do? And there's some recent examples. So I wrote these slides last year, and there's probably another more topical one. A big international company that did meat processing got a ransomware attack recently, and they had a large division in Australia. But last year, a couple of times, I believe, Lion Nathan had their factory shut down for various reasons. So that's like at the far end of the supply. Well, it's actually not the far end, but it's downstream from the farmer. But I suppose if you're growing barley that supplies a brewer and the brewer's operations slow down, it could interrupt your own orders. So one of the remediations for all this is how to worry about continuity planning. So people think of cybersecurity, they don't realise it actually includes an aspect of continuity planning or disaster recovery. So we have rubbish internet. So how do you make sure your machines and your IoT systems work without internet? How do you work around if there's a bushfire that interrupts, that causes a problem, or flooding or cyclone or any of the other reasons? And of course, protecting the farm's data if you have a disgruntled employee, for example, or even just from human error. And of course, farming being a business and with its own special areas to worry about has all the areas of compliance where computer systems can help you keep track of that, but then you need to make sure the computer system that's helping you keep track of that is secure. So Farming, believe it or not, has a security environment that's actually complex, but often overlooked. And so the purpose of my talk today, because I have I guess, a bit of an interest in security and also in agtech, having worked in it. I'm not building anything currently, but I hope to, again, at some point, build agtech work again. Make sure that it's secure. So I'm just trying to raise awareness about keeping security in agtech. So if you have a system you're building, it's on the farm, how do you secure it from various angles, including human security, equipment security, mitigation against disasters, and considering what other systems the farming computer system might connect to and which way it flows. One thing to consider, that as more and more large organisations up their ante on security, they will flow down requirements on their supply chains, which will include farming potentially. So that's another reason to worry about this. And basically that's where we get to the challenge, which is why I'm just raising awareness tonight, is how can we take information security management and make it accessible to people in agtech and in farming, what I've called translation into normal people speak. Because if you rock up out there with your IoT gadget, they're already dealing with LoRaWAN and Ethernet and all this other stuff, and then you throw on top of that, now we've got to worry about ISO 27001 and this security standard, whatever, they're going to glaze over even more. So trying to find ways to bake this into the systems we build so that the security gets simplified is an important thing to consider. So that's the end of that. I can probably let you, Ali, you there?
Hey, Andrew, yes.
Yeah. So I'm done. Hopefully I didn't send anyone to sleep, because the whole point is really just to say, look, there's this whole area related to what we all like doing that we might not think about, and it has an impact on the people we want to help.
Definitely. And I think you definitely touched the nerve on a few people in the crowd there. And I know Developer Steve, you have a few questions. If anyone else does, please feel free to put them in the chat as well. We'll make sure to ask Andy before he runs off to take his wife to dinner.
Actually, I do. And like, I have loved IoT things for absolutely ages. But I mean, as we all know, like embedded firmware, well, it tends to be a little bit basic as far as like code and infrastructure goes, but so integral, like you were saying, to that whole supply chain, like infrastructure, like so many things. I was also following that particular meat, we won't name them, but that particular meat company infiltration, let's say. How often do you see things like edge deployments used in literally in the field?
You're asking me how widespread are devices in farms, or
more edge? So like those little tiny devices all talking to it, because you kind of touched on the whole offline limited connectivity, where edge devices can kind of help with that, with the deployments.
Yeah. Well, I know LoRaWAN's one of the ones that's taking off, and they have all standards and stuff where they're actually, there's LoRaWAN and then there's LoRaWAN, and so I attended a virtual conference for the Things Network conference. I don't know if some of the people have heard of that in the audience. There's a thing called the Things Network, which there's a couple of guys in Adelaide that run the local Adelaide branch of that, and that's about LoRaWAN and LoRaWAN networks more from the community side, but they also interface with business, and they've got all standards they've now dreamt up around managing firmware updates in the field and that kind of thing. So a lot of people are looking at that and working on it, because it's just going to keep growing and growing and growing. I know James in the audience is looking at all sorts of different gadgets and things.
Yeah, actually, that kind of leads me to my next question around over-the-air updates, because I mean, from a security point of view, how critical is it to secure that as far as like an attack vector goes?
It probably depends on the type of device, to be honest. I didn't really touch it on this, but a lot of people go from nothing to just overdoing it without actually considering the risk of the thing they're actually looking at. So if you had a gadget out in the field and all its job is to report the temperature once every 4 hours, that's probably less critical that its firmware gets updated than something that can, say, turn on a valve on a tank and empty all the water out of it.
Yeah.
So part of the challenge is working out of all the different gadgets and things, which ones do we actually need to fix first or make sure are secure first? So yeah, none of this stuff has an easy answer.
No, that's all right. Actually, that kind of brings me to my next question. And again, if anyone has any questions, pop them in the chat or in the Q&A section. But what's some ways, obviously SaaS or software application security testing is only part of this, because in normal security, cybersecurity, you're just scanning an application running on a server or something, whereas this is an actual device sitting in a field. What's some ways that you can secure the hardware as much as the software?
Well, one of the kind of rules of thumb in security is if you've got physical access to the hardware, all bets are off. So
yeah,
I guess if you're trying to secure communications from hardware that you can't necessarily tell whether someone's tampered with it without driving 10 kilometres out to the middle of a paddock and looking at a tamper-proof seal, is I guess using all this. Again, these are all technical terms, but there's systems like public key infrastructure where you use these things called security certificates, which use cryptographic magic, if I can use the term, to confirm that what you've sent it and what you get back, it hasn't been modified. That stuff is actually very hard to do correctly and not put bugs in, and it's been a source of lots of well-known bugs in lots of well-known systems, and it would apply just as equally to edge devices as anything else. I know the recent LoRaWAN standards include techniques to address that. Again, it's something with no easy answer. There are ways to do it, but often, of course, that adds to the cost and complexity of the thing, which then often gets prioritized down to a point where maybe it shouldn't be.
Yeah.
And probably not really much of an answer, but
no, that's fine. No, I think even like knowing, I've been tinkering with IoT stuff for ages, and knowing like the capability of these tiny little boards you buy for like a few dollars, like, yeah, I agree. It's one of those really tricky things with no easy answer to it. Even just adding a simple switch on the side or the inside of the case so that it opens is still, I mean, you can, if you know where it is, you can get around it.
Yeah. Oh, it's like
yeah. That's actually, I didn't know that about LoRaWAN though. That is cool that they've got a security or some security stuff being built into their network protocol.
Yeah, there's a bunch of stuff now about doing over-the-air upgrades and security and this and that. Like, it's incredibly detailed. I haven't actually read it because there's too many of these things to read. But it's like, if I was going to build a thing with LoRaWAN, you would have to almost go and read this stuff so you can do it properly and learn about it, if that makes sense. So
yeah.
Cool.
That was a really good talk. Thank you. And very, very timely, because I know, sadly, ransomware and sort of cyber attacks, they're on the rise now, particularly as, countries are in lockdown, restrictions are in place, everyone's moving everything they possibly can online. So, no, very timely talk. And particularly with food production, like, I'm a big fan of agri-tech. I love FarmBot, just saying it now. FarmBot's one of my favorite projects. No, thank you very much. And if we don't have any other questions, no. But yeah, thanks for the talk.
Yeah, thank you so much, Andrew. I really appreciate that. So thank you for coming to. Thank you, Ben and Michael. Great to meet you again. So me and Michael worked together. We were colleagues a few years ago now. So I met Michael there, and I know he's a mechatronics engineer with a really big passion for Agtech, and he's also got an awesome parrot called Candy. And you are vegetarian and a drummer. So we've got like a musical vegetarian Agtech in IoT event tonight. On that note, I'm really looking forward to your talk, talking about Agerris, which is an amazing Agtech startup community, and also touching on that concept that Ben was talking about before on AI in IoT in Agtech as well. So on that note, I'll let you get started. I'm looking forward to this talk. Thank you, Michael.
Great, thank you so much. I'm going to just share my screen, and hopefully all these videos work. So I'm from a company called Agerris, and we are an Australian field robotics startup. We're interested in building intelligent automated solutions that operate in outdoor environments. And in this talk, I'll be focusing on our work in agriculture. Agtech is a really interesting field for robotics and artificial intelligence because you have these huge semi-structured environments that are also continually changing all the time. And because of that, having an intelligent robotic solution has the opportunity to make a huge impact on how farms operate and how they perform. So I'll talk a bit about how, like where Agerris has come from and where we're heading, where we're at and where we're heading as well. So as I mentioned, we're a field robotics startup. We spun out of the University of Sydney, and the technology is based on technology that was developed at the Australian Centre for Field Robotics. So it was lots of research went into this from there. And just a couple of years ago, the company Agerris spun out as a separate entity with the goal to productionize that into the hands of farmers. So the objective of the company is to address the issues that are common to farmers in Australia and around the world. We work closely with farmers, and that sort of informs and improves the technology. And we also, in turn, kind of, we fund some of the ongoing ag research projects at the ACFR. So that's kind of how the three entities are intertwined. Over the period of 15 years, the ACFR received over 25 million from the grains, horticulture, and meat and livestock industries to support research and development in the ag tech space. So there's lots of interest, and there has been for a long time, lots of interest in having automated solutions out on farm. And that technology started with aerial robotics that were tracking invasive species. And so the ACFR was building these unmanned aerial vehicles before they were even called drones, and they have the advantage of covering really covering large areas very quickly, but are limited by the amount of payload they can carry, how long they can operate for. There's limitations on the sensors, the compute power, and all these things are being addressed continually with as technology develops. But probably the main limitation that they run into is the inability to physically interact with the environment around them. So that led the research to move to ground robotics with the aim of doing crop intelligence and attaching tools for object manipulation as well. So over this, the period of time that the ACFR was researching in this area, a few different platforms were developed, and the robots were tested at farms all around Australia. They were also taken to the Asia Pacific region to demonstrate the technology over there, as well as understand what's common to farmers in different regions and what's unique as well to farmers in Australia. Along with the robotic platforms themselves, a lot of research went into, there was a strong focus on the artificial intelligence component. And this was driven by the need of the robot to be able to make observations and interact with those detections as they're being made. So the research looked into everything from detecting tree crops, row crops. There was continued work on the invasive species in large open terrains, and that leads to a lot of questions around path planning, not just of the robot itself, but of the implements that are going to interact with them. And also looking into how other robotics and computer vision tools, for example, can be used to, what are the applications for agriculture. The bottom image there showing an example of a computer vision technique called photogrammetry. Is used to stitch together 3D models from 2D images, and that will help to estimate volume, for example, of a crop. The robots were given a number of implements for object manipulation, and some of these are shown on this slide. So on the top left, there's this specific type of weeding tool, which when the weed was detected, it would just kind of scratch it out of the ground. And if the weeds are small and the root systems are very short, it's quite easily they're quite easily destroyed by something as simple as that. On the robot arms on the top row, we have ones with shears, grippers. They were looking at things like tree thinning, which you can use to sort of redirect the energy of a tree, whether it's going to grow new shoots and leaves, or whether it's going to focus that energy on fruits instead, just the crops. The middle image was looking at energy efficient path planning. So how do you fill the information gaps about the apples on that trellis using just the minimal amount of movement of the robot arm, which was just had a front-facing camera on the top, and of course gripping for picking fruit. And then on the bottom left, there was a model trained to detect, I think it was like rubbish or bottle caps, and you would just point a vacuum at it and allow the robot to keep the farm clean. And then on the other two images, we have a side-mounted and a underneath the robot-mounted precision spraying unit that does some very rapid-fire precision spraying. So I'm going to show. Hopefully, this video works. You can see the real-time detections from these apples, and this precision sprayer moving very, very quickly. But you can also see, like, if you want to cover that many targets, you're going to need something that moves very quickly and reliably. The detection's happening in real time, and also it has to be extremely precise. Otherwise, you're going to be carrying a lot of payload. So if you don't want to carry that much chemical, you're better off getting something that can be extremely precise instead. Other types of implements that were used, there was a non-chemical weeding, just using mechanical tines, and also looking into some lasers. And the lasers in this study weren't trying to burn the plant, but you just kind of heat up the plant cells enough to destroy the cell wall. And with the cell walls destroyed, the plant just kind of suffocates. So that was one area there. But of course, there's huge trade-off with the amount of energy required to do that. So over all this research, this particular robot here that later became known as the digital farmhand was evolving. And it started off as this two-wheel Segway-like drone that just followed GPS points and took data readings. Later gained additional wheels so that it could carry more tools and larger payload. And then on the bottom left, it was redesigned to move the motors and get some larger batteries into these side pods. And this was a big design change that was a huge step in creating something that's modular and adaptable, which was important because the bed widths will vary from farm to farm, and it basically just depends on what kind of tractor that they want to use at that particular farm. So it could be a 5 foot, you could have these 5 foot wide beds or 6 foot wide beds, and it varies for different regions as well. Having something that you can compress was beneficial for transporting the bot around, and then expanded for different row lengths. Just makes a lot of practical sense. And then the final iteration, or one of the latest iterations rather, is on the bottom right, where Agerris kind of took over. We refined the design further, added more sensors, added more of a robust design to it. We reworked the software as well, and it was sort of like a ground up redesign there, with also a change in perspective of, this isn't a robot that's going to be used by researchers who are going to run commands on terminal anymore. This is going to be used by people who are out on the farms. Yeah, but what we did keep was the goal of keeping this as a low-cost solution that's applicable to as many farms as possible. And that's what the digital farmhand is. It's a modular system for all cases. So if you want to have a compressed or a stretched out bot, if you wanted to turn it into a 4-wheel drive bot, put a solar panel on it, or extend it vertically for tree crops, this is like an all-in-one kind of solution. And here we can see one of the projects with this digital farmhand out on a farm. We've attached a boom sprayer to it. So each one of those blue nozzles with the light underneath will give a targeted sort of mist of chemical, and there's a small blue tank up on the top. This is a tree crop version looking at table grapes in Victoria. And there are many of these robots now on farms across Australia and in New South Wales, Queensland, and Victoria. From an engineering design perspective, it's really great that we have the opportunity to go on so many farms and partner with so many interested commercial farms to get the robots on there. It gives us the opportunity to understand what the farmers need, what the edge cases are to build a better product. And from a data analytics and machine learning perspective, we get data shared between all the robots. So you can have a robot on a lettuce farm in Queensland learning about what lettuce are and sharing that information with robots that are deployed in Victoria and New South Wales, and they all get a better understanding of what a lettuce crop is. All those detections start to improve, and you can then get a robot that's fresh out of the manufacturing, which we do in New South Wales as well, and load it up with whatever model is going to be required for it to operate on whatever farm it's being allocated to. This video is demonstrating the sort of tight coupling between real-time machine learning and the robotic implement. So to be able to target these very small weeds with in a mechanical way. So it's chemical free, and it's got more applications for organic farms as well. And it does require us to be able to not only make the detections in real time, but then fuse that information with other sensors on the bot to be able to get the position of a target in the real world relative to where the cameras are. So this here is showing again the real time. The weeding is something that is sorry, let's see if we can get that play. The weeding is kind of the primary interested in. They see it as the biggest benefit because you need something that is continuously working away at removing the weeds because of the way, just the way that they're stored inside of the soil. They'll be like a seed bank. So even if you invested all your time and effort to remove every weed that you can see, they will just continue to pop up. So the long-term solution is to have something that's continuously going up and down, removing the weeds as they're very, very small, and you'll get the impact of that. You'll feel it later down the track. But as a side effect of the weeder having to avoid all the crops, you get a lot of information about the crops already. So if you're detecting the weeds and detecting the crops just to avoid them, you already know where they are in the real world. You know then what you have a decent size you have an accurate actually size estimate of that crop, and also its position, its geolocation as well. And some other cool things you could do with fusing the sensors data together is you can get, for example, broccoli head sizing, which has implications for a lot of the downstream supply chain decisions that farmers are going to make. So they might say, you know, I'll only schedule in harvesting when 70% of my broccoli are between, say, 10 and 14 centimeters. But they could also be faced with a difficult decision where they know a cold snap is coming. This cold snap is going to change the color of the broccoli from green to purple. So how many of my broccoli can I harvest now to get that nice green color that retailers like, and how many, you know, and how much of it is going to just, you know, it's going to be affected, turn purple, and then it ends up being graded as a little bit lower, and they have to sell it for less. So those are the kinds of things that we could try to help them with real-time data, or as close to real-time data as we can get. If the bot is continuously performing these data collection exercises, these weeding tasks, then they can get something that's really up to date. The other benefit of using a robot for this is the weeding activity is that it can see things that the human eye just wouldn't even notice. So these tiny broadleaf weeds that I've zoomed in on the left, they're about the size of your little fingernail. And they are the best targets for weeding because they're just so easy to remove. Their root system will be very, very short, and it's very energy efficient for the robot to be able to just kind of scrape the surface of the bed and pull them right out. The other benefit is that by not disturbing the top layer of the soil, you preserve the pre-emergent chemical spray that would have been put there before the seedlings were planted, and leaving that undisturbed also has a huge effect in keeping the weed pressure down. So the lot of focus has been on the weeding, and as I mentioned, the crop intelligence part was very much like a side effect that we get, or a side benefit that we get, that we can provide to farmers. When we show them the data, that kind of thinking kind of flips around a bit, and they become more interested in the data than the weeding itself in some cases. So here we have just a dashboard that we did for a client. Being able to show things like the counts of crops is something that is, you know, with this level of accuracy, when you can have detection models with, you know, over 99% true positive accuracy. These counts are things that farmers probably haven't seen. I think historically they will do things using planting rates and estimations of the planting area, but we also get additional information about the size and the geolocation of the plant. So we flagged a few anomalies in red on that little map, and if you when we take all the different data sets from the same row, so the same row taken at different times by the robot, we can use data registration algorithms to map those detections to one another, and then you can have the crop history for each individual plant shown to the user. And you might not want to dive in at that level, but being able to see what happened with an anomaly, for example, when it died, how each individual plant is growing week on week, that you can start to do things like you can build up a model of what a healthy plant looks like at this time of year for this type of crop, and plants that aren't sort of meeting that pattern, you can flag them for, you know, possibly they could be diseased, and you can build that confidence up over time. Or the other thing you could do is allow the robot to try and treat or make decisions and take actions about what you do with these kind of statistical anomalies. So there are these natural chemicals that you can use to just sort of like boost or slow down the growth rate of a plant, and being able to see what's statistically too big or what's statistically too small and treat that to promote uniformity of the crops along the entire row or the entire block it's very beneficial for a farmer's business, just because it makes things extremely efficient, extremely simple in terms of what they're going to do with their supply chain later. Being able to look at different varieties at different points in time and pull external data about the weather patterns and microclimates is something that it probably couldn't be done before without an automated platform that's continuously collecting data. So now you can start to answer questions about what works, which varieties do well in different, so which varieties perform well in different regions, or if you want to compare the same variety across different regions. And that's really important for Australia in particular, because the rest of the world uses Australia as a sort of counterclimate. So it's such a big continent here that you can get a sort of a good representation of a climate in Europe, for example, within specific areas of Victoria. And if we know that it's going to be a cold, dry winter coming up, you could test different varieties in Victoria, and that can inform the purchases for farmers overseas. Similarly to the crop information, we can do the same for weeds, just showing like what the distribution of the weeds are, where they're growing. It could link to some infrastructure anomaly on a farm, so like a leaking irrigation pipe, for example. You could spot lots of weeds popping up there, or even just understanding what the impact of the robot weeding implement is when you use it, when the bot's on farm. This video is just kind of like ties everything together to show how the system kind of looks to the user and what's going on the inside. So it's autonomously navigating, it's doing the end of row turn, getting back onto the row. These detections are continuously being made, they're stored, they're thrown up into the cloud, where we could do additional analysis on them to understand, let's do some denoising, we'll register the data to the previous time the bot was on the same row, and get some temporal elements to the data, as well as just the latest snapshot. Okay, so where I think this is all heading next, I think farms will be changing their processes to incorporate more autonomous systems. As was mentioned in the chat earlier, COVID was a big, it did result in a big uptick in the interest around robotics, because you just can't get workers onto farms anymore. The data will be shared across many different IoT devices, and some sort of middleware is likely to become a big part of tying all those devices together so that they can communicate with one another. And finally, I think the robots will end up making more autonomous decisions driven by the historical data they collect. So tying the robot decisions up to what the historical data that's stored in the cloud is, having the robot query that and decide, how am I expecting, how large or small am I expecting these crops to be, and act accordingly using that information. Okay, thank you so much.
Yeah, wow. What an amazing chat and product. Sorry, I hope I'm not echoing there. And I know so many people in the chat are just going, oh, what an awesome invention. And so am I. Like, this is tech for good at the right level. This has got a useful purpose, and you're collecting all this ulterior data. Well, I don't know if we call it ulterior, but I'm using it. All this extra data, I guess I should say, that can also help you become a more efficient farmer. So, I mean, this is a really big win-win here. From what I can see, and you can use it on all sizes of farms. So yeah, really impressive work you guys are doing there. I love it. I think Michelle does as well. Just before we move on to you though, Michelle, sorry, because I know you've got a few questions and comments to make from another event that you've been at. We do have a few questions from the audience, if that's okay, Michael. So the first one's from Zen. He wants to know if you know OpenAI, and would you mind sharing your thoughts on them if you do?
I don't know OpenAI, unfortunately. Sorry. I do a quick Google search after, and we can chat on the tables.
Yeah, sounds great. I think, is OpenAI the say people the one that Elon backs and they won a Dota contest with it? Is that the one you're talking about, Zen? Correct me if I'm wrong. I went down a YouTube rabbit hole the other day and that came up. So let me know. Otherwise, we'll have a chat on the table.
Know what your algorithms are recommending you.
All sorts of things. I went down many rabbit holes, believe me. I watched a great documentary on AI the other day. But anyway, so, as you do with YouTube, right? On a Friday night in lockdown. No. Developer Steve also asked, do the robots also share the data between themselves on the same network? So fog computing?
So we have multiple robots on farm, and they don't share the crop intelligence data, and they don't share images. So that goes to the cloud instead. But what we are working on is just the location data. So I think the way that you want the autonomy to work is for the bots to sort of query the historical data that we stored up in the cloud and understand, what was, a simple example would be like, where did we finish off, and where are we going to continue from? And then between themselves, like you can make some pretty basic heuristic sort of algorithm, like decision systems, to decide which bot is going to do which. If you were doing chemical spraying, you may want to increase the amount of internet connectivity between the bots, because you may have one bot saying, okay, I'm estimating that I'm about 50% of my chemical, that I have in my tank. And then you could have a bot sort of replan their path on how much ground that they're going to cover. Would be one use case for that. But because we do things mechanically, there's no real benefit for the robots to be able to communicate with one another, other than to sort of decide where each of the bots is going to operate for for a certain task.
Yeah, makes sense. We've got so many questions coming in, Michael, so I hope you don't mind. We could be here for a little while. So Developer Steve also asked, what sort of cameras, and feel free, if it is like your IP, that's fine, just let us know. But he asked, what sort of cameras do the bots use for weed detection?
So because this is designed to be a low-cost robot, the cameras aren't really anything special. They're just regular machine vision cameras that are RGB. And the sort of IP part comes in where you're trying to use where you're trying to geolocate that detection in the real world. So being able to attack it with an implement that's the time's only an inch or a couple inches wide, to get a target that's less than a centimeter in diameter. That's where the sort of complicated part is. But the nice thing about just using very simple cameras is that when we do tree crops, for example, you can have a whole camera array using the same solution for the ML part.
Yeah, awesome. And there was some impressive accuracy, even with what you say are cheap cameras, which kind of leads me into a question from Ilan Govan as well, who's asking if we can have a rough idea of the cost of the Agerris digital farmhand.
I think they're so we provide the service at the moment, but we expect the cost to be something like, I don't want to put a number to it, but general number might be something like $100,000. When you put that in the context of farming equipment, it's not expensive compared to, say, a combine harvester, which could be $800,000, but you only get to use it maybe 3 weeks out of the year. This would be something that runs continuously every day and is always working for you. So I think that's the way it's kind of framed in farmers' minds.
Yeah, and I think when you put it into context, if someone's going around and you're paying for people to weed this as well, and you're not even getting data on your crops doing it that way, I mean, it doesn't take long for that to pay itself back, does it?
That's true, and the trade-off when you have people going out there to do this manual weeding is that they aren't doing the more complicated activities, to do with like warehousing and packing. Sending things to the right places, grading the crops as well.
Yeah.
Weeding is one of those tasks I think that is left till it's really a problem, and then if by that point you're already kind of losing the battle.
Yeah, definitely. No, it's a really great use case. So about 4 more questions. What sort of batteries, power generation are the bots using to run everything?
We use lithium ion, because they're the safest ones for the size that we're getting. The bot runs for about 8 hours, and my hesitation there is because it depends on the soil type. So if you have like really sandy soil, the bot uses more energy. But as we have in the image there, that solar panel makes a huge boost to the longevity of the bot, like on a single charge. So it can go up to 16 hours with that on.
Yeah, it's great incorporating some sustainable energy boost to that as well, and in a really useful way. So really cool work there. Zen Lee asks, the dynamic range of the camera is really good. Are they expensive? And I think you've kind of already answered that, but maybe you can go into a bit more detail there for Zen.
They're not super impressive for the other kinds of products that are out there. You can have cameras that have the machine learning running like on them as on the device itself and just passing through the inference results. But yeah, I guess we are doing from a computer vision perspective, and small changes in the dynamic range is already something that can be learned on. So if we're trying to pick up, I mean, on this farm in this image at the moment, we're picking up crops, we're picking up weeds, and it's all sitting on top of moss as well. So it's like it's green on green type of detections, and I think it's more to do with the machine learning models having the right training data to be able to differentiate between these different classes.
Getting the right data to train your models on, always the data scientist's biggest problem, isn't it? Anonymous asks, do you also build the robot or just put the intelligence on it? And I think you kind of answered that you're doing the services, but I'll let you take that one.
No, we build the robot. So we designed the robot, all the components to it. We were building them in the lab, and then now we've sort of settled on a design that we're happy with. And we want, so we have a manufacturing partner in New South Wales that pieces them together, and we just drop in the software now, but it's all of the Agerris design.
Yeah, really cool. So doing the whole thing here at Agerris. 2 more questions. James asks, there is an Australian-based open source weed computer vision database that's available / growing. Is that something that you know about?
Yeah, we've been approached by a couple of different bodies that are putting these data sets together. The platform that we have, you end up having, because it's done so many rows, it's done so many crops, it's seen so many weeds, you end up seeing a lot of the same ones over and over again. And the platform is, the main benefit of it is that you have a kind of standardized view of the targets that you're trying to train on. So if you have a database that's full of, you could build a model of oranges, for example, by scraping Google Images. You won't get it as a good an understanding of what that is running on this bot as compared to if it just trained on the sort of camera view that it sees all the time anyway. So we haven't really made use of any of those. The other interesting thing about the machine learning is that we have so much data that we don't have to use jumping off points. So like ImageNet or DetectNet or one of these ones where you have 80 different classes inside of a machine learning model, and then you tune the model to certain classes, customize it for just a few. Instead, we can go all the way from the ground up and build a model that's only ever seen different types of crops, it's only ever seen different types of weeds, and we think that will that leads to better performance overall as well.
Yeah, awesome. So James has a follow-up there asking if it's something you're contributing to, but maybe that'd be a good chat to have on the networking after this. So maybe James, you can jump over and have a chat to Michael after this, because it seems like you've got a few questions. Last question for you, Michael. Do you use any type of wireless connectivity to send data, or is it local storage?
We do use wireless as well. So the bots are on their own network, and to control them, we have used LoRa as well. So you could do you can control them from very far away and emergency stop them, get feedback to the user interface about hey, I see an obstacle, I can't get around it, or I'm stuck in the mud, or things like that.
Awesome. Well, thank you so much for coming up and promoting so much chat between our IoTers. Obviously, a passionate subject here, so really appreciate the time tonight too, Michael. Michelle, if you're there, I think you had a few things to say as well. Hey, Michelle, because I saw you talking about drones and AIIA and some adventures you've been on recently.
Yeah, I absolutely loved all the presentations we had today. And Michael, I loved how you were always questioning, like, this is a way to, kill weeds, but is this more energy intensive? And then proving how you've sort of offset that with other ways. I just love everything that was going into that. And data is everything. And using it in a really good way to make, more sustainable, sometimes organic, like food and vegetables and stuff for us. So that was awesome. I was in the chat thinking about South Star and all the cool things we learned there too. And yes, I wanted to share a couple of upcoming events. So as you guys know, I am in Adelaide, and last week was meant to be the Advanced Ag Conference, so showcasing South Australia's Agtech. It was postponed, unfortunately, but I guess fortunately it means that everyone here now has a chance to think about it. I don't have a new date for Advanced Ag, but I will be there at the Telstra booth to answer questions about the narrowband IoT and Cat M1, like cellular IoT network. We've had a lot of talk about networks and stuff today too. So I won't talk about it today, but maybe in another meetup, or come see me at the Advanced Ag booth if you guys get a chance. And on the next slide, Ali, we've also got the Adelaide Agtech Meetup. So Ollie, who was one of the masterminds behind the South Start conference that Ben mentioned before, hosts this meetup pretty regularly. So usually they are in person, and it's pretty fun because they actually go out and do sort of on-site adventures, so going to farms, going to wineries, and they recently had like an overnight meetup as well, where they actually got to go onto farms and talk to the farmers there. So if you're ever in Adelaide, or if you're not, follow it and see if they do anything near you. So that's all right, James. It'll be postponed later. Yeah, so that's pretty much all I wanted to say for the upcoming events. And then the next slide is probably announcing our next AusIOT meetup. So today was really awesome. I like how Ali got together some speakers that were in a similar theme, like Agtech, and I think we've got a really good turnout today, actually, and great engagement in the chats. Obviously, you guys liked the agriculture Agtech theme. If there's another theme that you guys want to talk about, if you want to host one of the hybrid hubs, so imagine we're all here virtually, but you could be in person with a couple of close friends and colleagues, let us know. If you want to speak or you have a good speaker, let us know as well. So our next meetup, I think we've got 18th of August in the calendar, but we'll send out a confirmation. Yes, conditions permitting, of course. Sorry, developer Steve, thanks for reminding me. Us here in Adelaide are out of lockdown now, so whatever's safe to do so. Yeah, so that's next month.
100%. Thank you again to all our speakers, Michael, Ben, and Andrew as well. And we will get off this presenter mode and let everyone have a cool chat on some of the projects they're doing, or just some of the tech that you've seen tonight, or some of your passions you've got about Agtech on the tables. So thank you again, everyone, for joining us, and we hope to see you in the Discord or at next month's AusIOT. Cheers.
See you in the table.